Hi. Yeah, so my talk gonna be about tempo or musical time and the audio, like our wall time, which usually we end up with discrete samples. For the technical ones, you can scan or go to this GitHub and you got the entire code here because this talk, I mostly did it as the Git commits that you can follow and see everything. I'm gonna have the presentations also. So first, before introducing myself, just like what's the motivation in the story, that's gonna be a short introduction. So that's me there, and that's a great drummer, and there's a click between us. So I usually play, like 10,000 people. It's shows when I perform. That's another thing I do except for music. So it's less stressful than being at ADC in this room. So yeah. So first, who am I? I am musician first. I started as a musician, as a studio engineer also. During that time that I performed and did a lot of studio work, I learned and did some CS degree. And I ended up being a developer at Sound Radix that you should really check us out. And if you want to meet very great developers that are, I admire every one of them, and they've been really helpful. And I'm still performing less because I need to fix bugs and add features for products that I feel that, from being a musician, I struggle every day with. So the story starts with every common session in a studio or a performance that you got the drummer and he hears the clicks the first time, it's like, or something, and then it says, no, that's not my click. I need a wood block or a cowbell or whatever. And you're like, oh, how do I do that? So each host, like each digital audio workstation, whether it's Cubase, each one got their own opinionated click sound that you can change it. But even though you can change it, it's not that easy and it's not portable. So there is no one solution for that. Well, there is now. I've made an open source plugin for that that you can also run in your phone. It also works as VST, whatever, anything you pretty much want. Raspberry Pi, not yet. I need to compile it to ARM64. So yeah, it's really nice and simple. Like, we had here crazy talks about AI. How do you do pitch detection, pitch following, and crazy DSP? So one common thing I saw in all the other talks was that usually there are some gotchas that like, we need to change the buffers, and this is like in a hardcore sample rate or buffer size. So it's simple, but not straightforward. That's the talk. It's gonna be mostly like, I'm gonna go through code that I made a very simple metronome. We'll see that soon. So what's tempo sync? The simplest tempo sync or the naive thing is that we got an audio process that got, blocks of buffers, and we got some value, musical value, let's say an 8th note, a 4th note, it can be dotted, whatever. And then we got the delay in milliseconds. So we need to get this number into our sample time. Okay, we here simply convert it from the BPM, the bit per minute, to seconds, then to milliseconds, and then we multiply it by the sample rate, and we got a value of how many samples, like what's the delay should be. So yeah, we got tempo sync. That's the entire talk. No, it's not really, because usually when we talk about tempo sync, it's really misleading name. Like I Googled and I tried to find a better definition or something. I think it's more musical sync or understanding the musical context and being able to follow it. Why is it useful? So you want to sequence things, you want arpeggiators like and you want it to be on time. LFOs also can sync. They even sometimes can use the simple way, but depends on your use case. Drum machines, of course. External devices, of course. Yeah. So the core thing to understand is that musicians understand time differently. And anyone that went to or had rehearsal with a band know that some drummers come a little late. No. So the core thing to understand is the wall time. Like our time of, this is like clock. We are basically expecting that every second should be the same. And ideally, this is something that we hope that works. It should be constant. Musical time, ironically, is the same. What we mean the same? We expect absolute lengths of a quarter is a quarter, an 8 is an 8. But the additional factor that we got is the BPM, the tempo. So unlike the 1 second, that's always 1 second, the tempo can fluctuate or change during the piece, the musical piece. And then each quarter can be longer, shorter, it can change. Or an 8 is always the division of that, so it's just the ratio of the quarter. Another thing to remember that musical time notation, like we have a bar, so usually we expect the bar to be the same size, even though the music can change, the tempo, I mean. Let's add the digital domain because we are audio developers for software. Yeah, so audio sample is, I guess everyone in the room knows what it is. Because we are working in discrete domain, we are sampling the time. So when we are talking in 1 second, we want to do a sample rate, like we want to capture the time every, we capturing the time in specific intervals. And this interval is the sample rate, and it should be higher than whatever we want to sample, Nyquist, Shannon, all the great theories that are very critical when you are doing filters and other things. And we got the digital music unit. So that's something that invented, I guess, with the MIDI mostly. And they decided on some arbitrary, or at least that's how I say it, timing that's called PPQ or TPQN or PPQN, which means basically pulses per quarter note. So now we got digital digital instruments, musical interfaces that are talking in PPQs. They're just like taking quarters and saying, okay, we can divide this quarter into 24 pulses. And then like, what's a quarter? Like the quarter changes based on the tempo. So again, it's a little tricky to understand. Here's a summary of this with BPM. We started with a static 120. So 120 means that we got 2 quarters, if we're in time sequential quarter, 2 quarters that are being every 1 second. And if we look at the PPQs, this is, I wasn't able to do something, so it gets aliasing and horrible effects, but basically the PPQs are changing and they're based on the tempo. As you see, we are accelerating and then like everything gets shorter. The wall time, the seconds are the same. The seconds for sample rates will be the same. Our audio buffer, we hope that it will be the same, but the host can do whatever they want, and it's also not symmetrically divided. So summary of all this, very short. We got here a nice software by a nice company. And we have here at the above visualizing the musical time and the wall time. And what we'll see is that when we are looking as musicians, that each bar is the same size, it means that the playhead will go faster, but visually we are seeing a bar is a bar. Wall time on the other end saying, okay, the time changes. So we can see this. Yeah, so let's start by syncing a metronome from audio. So like in any cooking class, we need a recipe. And we start with the PPQ position. That's basically a counter provided by most audio hosts. It's the JUCE way. We're using JUCE here. We get it always normalized, meaning that we got a float number or a double number that's saying how many quarters are passed and what's the normalized ratio of the current quarter. So instead of using the pulses, like if we had 960, which is a common pulses per quarter, like we divide it by 960, if we have such a resolution of 1200 PPQs over a resolution of 960 PPQs, then we'll get 1.25. And the 25 is the current position that is a little after the first quarter. The other thing we have, of course, is the tempo that helps us understand how fast we are going, and the time signature. That, you know, there are 3 quarters, 4 quarters, 6/8, and more things that we'll evaluate and understand why we need them later. So as you can see, I have everything here as commits on what the link that I provided. Don't worry, you can also. I also have this link at the end. And what we can see is that first we have a very boring template that is producer and CMake. You can build it yourself. A tempo utils class that just gets the transport, which is what the host provides us of where we are in sample position, looping, a lot of interesting things that usually you want when you are doing any kind of syncing on of understanding your orientation in an audio project on the DAW. And the interesting thing in our template will be that in our process block, in our processing, we get the playhead from the host, and then we use the utility class to just calculate this struct or class we are getting. And one thing we add firstly was the last whole quarter, which means like if we go to the previous example, so here it will be the 1, like we don't yet care about the next, the current quarter that didn't finish yet. Okay, so now if we try this, we simply paint it with a timer callback on just painting the number. And as you can see here, very gently, we just got quarters counting, no sound yet. Similar to that, we can ask the host about the tempo and the time signature, no sound yet. But if we see that if we're, speeding up or changing the time divisions, we get this data. Yeah, so first we'll try to prepare for just doing pulse ticking at the right time. This demo, because it's designed to be simple, we are just having an impulse, one sample in silence. So we just mark where is the tick or where is the start of the beat. So the first thing we want to do is understand in samples, where are we standing? So we need to get the quarter into seconds. So it's simply dividing the BPM by 60. And then we want to know like the current unfinished position, like the in progress quarter and where it is until the next time it should tick. So now, again, we got displayed. This is the process block, our processing callback. We get those values, and then we calculate the quarter into samples, but in the previous one we had this in seconds, so now we just make it sample rates. And we simply move a counter. This counter is a member currently in this the current state. And yeah, and then we are doing a modulo afterward to know which sample in the buffer we should be to tick, and we tick at it. It's very naive, and but it works. No visual indication. We got the tempo, like we got a click. Next thing we want to do is just sync it up to the host, like kind of sync it up. It's not really syncing yet. So what we do is we take the next quarter, we simply get the sub-quarter division that we talked about earlier. In the previous one, we didn't use it. And yeah, we basically now don't need to count anything because we are based on the position that the host reports to us. And now we don't need a lot of boilerplate that we had before. And now, if we start, this is the Ableton one, but as you can see, the metronome is running. We are pretty much ticking at the same position. So what was missing in the previous, in this thing that we started to get everything synced? Anyone can guess, or there is tiny corner case? It should work if it speeds up. So one corner case, okay, there is one, I'll try to give a hint. You see the name of this constant their next quarter in samples. So it's the next quarter in samples. But what happens when we are at the first one? So what we need to do is handle this corner case that we are exactly on the first quarter, quarter. So now, if we start, we'll stop and then we'll start again. We'll see that it's always starting at the one. Any other? This is a bonus question, and interesting one for another corner case that it's super rare, and it's a gotcha that you might end up if you're doing something, I don't know. But it's not. It's something that I'm pretty sure won't happen in most use cases of this. Okay, so spoilers, no. We don't handle large buffers. So imagine that we have a very long buffer. That's something that's, BPM, usually for us, we don't want something that is crazy. So most buffers, even they are 496, would be enough. But basically, we just want to iterate and get all our ticks instead of, if the buffer have more than one pulses inside it. So this is something we should also consider when we are doing any tempo syncing. And yep, time signature. So far we had only quarters, but there are 6/8 and other nice things like 7/8 and even worse divisions. So first thing is, this is like I work in my company, and when I get code reviews, it's really important to refactor. So I refactor this from our company. So the name is now bit in samples and not quarter in samples. That's really important. And now we just want to get the ratio. So because the PPQs are quarters, what happens if it's 8? So in the case of 8, we simply wanted to tick twice at the same for a quarter. So we just divide this by the denominator. So for example, if we ate 4/8, so now it's divided with the 8, and then we get the ratio of a half. And now we are pretty much ready. We just need to do similar to what we had in the previous state the get last whole, we now can get the previous, but instead of a quarter, now we get the relevant division position and the residual of it. So where we are for the upcoming other bit. And then we glue everything just by mostly calling the new functions we made. And we got pulse. You can see now the tempo is faster. And we can change here. This wouldn't do anything, but the 8s would work. Even 16 would work. Yeah, so we got a nice metronome. So what's else missing? There is one thing missing. Anyone can guess? What? Looping.
Always seems to be a gotcha or tempo sync.
I'm not sure looping is. You can do loop yourself because you know everything, but there is one thing that if we hear the previous one here, so one very important thing for musicians.
Downbeat.
Yeah, the one. No, I thought I did it very cleverly. One more thing, one, but yeah, it's messed up. So beat location is a crucial part of music. I also, for the less musicians, like the more for the developers to understand this, so I saw this website, and here you can see some progress, chord progression, and how much the position in a musical time affects how we perceive the harmony. So let's see if the internet works. Yeah. Yeah, the 5th. So if we are looking at the same, yeah, this is the same thing, but in a different position on the music. So this is the same position, this not. So, like, if we don't know where is the one or how we handle the situation, then for musicians, it's less useful. So, again, refactoring. Sorry for those parts, but I need to do it for my reviews. And then we want to get the current beat, like what's the beat? Is it the 1, the 2, the 3, and the 4? And this is basically modeling the numerator. A question, why is there +1?
You don't want to start at 0?
Yeah, musicians don't know to start at 0. Musicians, we are 1, 2, 3, no 0, 1, 2, 3, 4, 0. It also sounds. So now, again, we just get this current beat. We need to do the +1 ugly again because we want the next beat and we get this iteration going. And what we do is we decide here if the next beat gonna be louder or softer. If it's the 1, we're gonna do it a louder one. And yeah. Again, this is sorry for this recurring motif of the talk, but now there is another major gotcha that I actually fall for with my personal metronome. Yeah, it was fun. Yeah, so that's a nice spoiler for this. I found some nice example that I made, so I'll also try to do it. Actually got correct, but Yeah. Actually, I got his bug report, and the guy sent me Gojira, if anyone knows them, which is death metal. So it's like a lot of tempo change said, my drummer is getting crazy. It's not working. So we know what's the problem. The time signature changes mess us with our accent. And is there any solution? That's the more ingredients that we are looking for. So there is less bar position. I don't know why they invented just okay. Like it seems like a afterthought in a way, because the less bar just giving us the less bar that had a 1. So now we simply subtract it so we can understand the current bit, but we doesn't care about the real position because we just want to know the bit. And now it's working as expected. So that's pretty much it. And I'll summarize everything. We used an impulse sample just for the example. So in actual products, we have much more complex situations that we need to know where to start, but then we need to know if we want to stop or fade things, or we have multiple layers, synthesis, sample rate conversion, because if you are playing samples, you want them to play the right sample rate. And also another thing that we didn't, it's another point here, so I'll mention it later. But you might also need to smooth some values because there are fluctuations. And the important thing to remember here that we always got the transport position, and we treated it like this is the truth now. So for example, each buffer got a position, but we didn't have our own counter or our own phase calculations. And the most important thing that I think this lecture, this talk is about, is that time and musical time domains are not friends. They are friends, but the moment we are doing conversions in especially in discrete values, but also in everything that can be infinite, then we're gonna get some numbers going wrong, and also musical events are treated as an event, a musical one. So if we are saying, let's play something on the 16th bar, and then we change the sample rate, so if we save this value as a sample, we are losing the information we wanted to save. So there are other reasons for that, but the core thing to understand is that keep your musical events in musical time and your audio events in the wall time, the samples, or even better in seconds if you want to be more friendly to sample rate agnostic. So I mentioned the Ardour one, the release notes, because they, just in version 7 that was a few months ago, they finally got the internal time representation. So they finally add some fixes related to those exact things. And this is like a major open source DAW. So it's a gotcha that I think that it will be great that if you want to do something, you can avoid it. And the other thing in our example is that it's a per block and not per sample. So we get our BPM and our position every block. So it's not sample accurate. Imagine that if we have a smaller buffer, we are actually getting more resolution of our position in time, at least with the conventional plugin. Time signature requires orientation. We talked about this, the last bar. Sadly, JUCE doesn't have the AX support. I wrote about it, and I think there is a PR that can be easily add this feature. Also, hosts start counting bars different. I don't know, some starts with 0, some with 1. And the another gadget that it depends what you're doing, but we only know the last bar position, but not what bar it is. So we just get quarters. So imagine you got a time signature of 3, 4, and 4 quarters or something. Then it's like we don't know how to divide and say what's a bar, because if we are getting every time the last time signature, so even if we had a bar of 3 4s and 4 4s, 4 4s, then if we are now saying we are in time signature 4 4s, I hope this is clear, but if not, because of time, I'll leave it, but that's maybe something to think about. Anyway, to solve this thing, the AX and also CLEP and LV2, from what I saw, provide the actual bar number, not just the PPQ, last bar, and all those elements. And ARA, if you are doing something that requires even more complex situations, provides a musical context that is much greater thing, instead of you trying to bookkeep what your host did and guess where you are. It's really important, let's say if you have some time signature changes, and then something that started at one position now plays in another. So it's another thing to remember. Yeah, so that's it. You can download and try it and report anything you see. Questions?